Hey, what's going on, students? Let's do the fresh scented tense. So we need to go to Desmos, and we're going to make a gravity function and answer some questions. So remember, your basic gravity function is h equals negative 16t squared plus vt plus c. You might want to swap out h and t for x and y. That's going to help. And then v is going to be the initial velocity, and c is going to be initial height. So I give you kind of the format. You got to make the equation. So here we go. So let's go y equals negative 16. We're going to use x to the second power. Remember, there's a keyboard down here, so if you ever need to type in exponents or other things, you can do that. Tell you what, I'm going to go ahead and finish things off with the keyboard here. So let's go plus. The initial velocity was 186, so 186x, okay, and then we're going to have an initial height of 390, so plus 390. Okay, so there's my gravity function. Let me double check. We're good to go. So now that we have it in there, we can kind of manipulate, and we can drag, and we can zoom out. So here's my gravity function. So I'm going to try to change the window a little bit so it doesn't look so weird. We don't really need a y-axis of negative all that noise, so let's change that to like -1. There we go. And then we don't need a x value of 500 and something. How about like 9? There we go. Ooh, that's way better. Go away. Yeah, zoom out just a little bit. There we go. Okay, that's a lot better. That's a lot better. All right, so let's take a look here. What do we need to find here? We have, okay, initial velocity. We have height. I think we're good to go. So we got to find the max height. Okay, so if we click on it, it does give us the vertex, I think, right there. So boom, there we go. Hey, there's the vertex. The vertex is going to be 930. It says nearest 10, so we say 930.6. Okay, so I'm going to go over here, and I'm going to say, gotta draw. Here we go. So 930.6, I think is what it's. Let me double check here. So gotcha, right there. Yeah, the vertex is right there. So at 5.8 seconds, it's going to be 930.6 feet in the air. Holy cow, that's quite a gravity function here. Height at 3.1 seconds. Well, here's what you can do, friends. You can kind of drag along the line and find out where it is exactly at 3.1, which is right there. Oh, there we go. If my steady fingers can hold it. Okay, or you can just do x equals 3.1. This is kind of cool. Watch this. X equals 3.1. It'll bullseye that point for you. Look at that. Okay, so you can drag along the line, or you can click, or you can do x equals 3.1, okay? Since x is the seconds, the t, the time. If you do x equals 3.1, it'll bullseye that coordinate point for you. So it looks like at 3.1 seconds, it's going to be 812.8. 812.8. So it's going to be 812.8 feet, okay? What time does it hit the ground, the projectile? I was going to say it's a ball. Well, when does it hit the ground? So here it leaves at 390, up in the air, 3.1. There we go, max height, and then it's coming back down, coming back down, coming back down. Boom, right there at 13.439. So 13.4 seconds about is when it hits the ground. 13.4. Yeah, 439. Yeah, we're not going to round up. So there we go. That's about it, friends. So all you do is you go to Desmos, you type in the appropriate gravity function. The negative 16x squared is always going to be that. You want to have your initial velocity be attached to the x. Then you want to have your height be the number that's all by itself. You might want to manipulate your window. Have your y values go from like -5. So this is a pretty good window right here. Have your y values go from your y values, your x values. Have your x values go from like -5 to 15. You can edit that in the window right here, the window editor. You can even darken in the lines. And then just zoom out until you can see all the items. And if you click on the line, it'll give you all the important corner points. So like here's the y-intercept. Here's the other x-intercept that doesn't make a whole lot of sense in real life. There's your vertex. There's your x-intercept over there. There's when x equals 3.1, there's the height. So just get good at using Desmos and editing the window so you can see all of the goodies. All we really wanted was the max height. We wanted the height at 3.1 seconds, and then we wanted what time does it hit the ground. So you can ask other questions too. When does it hit exactly 500 feet? So watch this. You can go like y equals 500. And that's exactly when it's going to hit 500 feet. It's going to hit 500 feet at 0.625 seconds and 11 seconds. That's kind of nice. 11 seconds flat on the way down. Cool. So any questions you might want to ask, Desmos will help you figure that out. All right, that's about it for the fresh scented tent. See you in class.